everyone, and welcome back to Aarav HQ. Today, I made a remote-controlled car with my new Arduino Uno R4 Wi-Fi. Let's check it out. Let's take a look at how I've wired this. So this here is my Arduino Uno R4 Wi-Fi. So first, the power source for the Arduino is either this USB that can connect to your laptop or external power source, or this 9-volt battery that can connect to the barrel jack. For my L298N, I have this big battery down here. This is also a 9-volt battery, but it has more power, which is needed to power the motors. This battery has a connector that goes around and ends up in these two wires, this green one here and this white one. The green one is connected to a switch, which you can use it to power on and off the motor driver, and the ground goes into the ground. This other black wire is actually a common ground for the Arduino Uno and the L298N. This is needed if you want to control if it goes like forward or backwards, or the speeds with the Arduino. For the forward and backward, I have pins 8, 9, 10, and 11. And for the speed, I have PWM pins 5 and 6. These all connect to the N pins on the L298N and the enable pins for the speed, so the green and the gray. The motors connect from down here into these two wires and these two wires back here. And as you can see, the car can go forward, backwards, left, and right. Let's go to the code. So to start, the Arduino Uno R4 Wi-Fi actually uses Bluetooth Low Energy. Bluetooth Low Energy is different from classic Bluetooth because it has characteristics, which are like values that you can update. However, Bluetooth normally has a serial-based feed. So you send text from one side and it goes to the device. Bluetooth Low Energy sends like this characteristic is being updated to a value. Bluetooth Low Energy also is much more energy efficient, as the name implies. So to use Bluetooth Low Energy, you first have to set up a service with a universally unique identifier, and then you can set up characteristics. So again, the characteristics is like a value. I have two characteristics here, characteristic left and characteristic right. This obviously stands for the speed of the left motor, and this is for the right motor. Now both of these also have their own universally unique identifier. Then you can also set up permissions. So BLE read means that you can read the value, and BLE write means that you can write to it. So up here, we set the pins. These are the two speed pins, which will map to the enable pins on your motor driver. And the speed will actually be controlled with these two variables, left speed and right speed. So the way I've done it is, if you want to go backwards, your speed will actually be like a negative 100, but we will actually map that to 0. And to stop, it'll be 100, and to go forward at full speed, it'll be 200. So 100 and 100 just means that it's going to be stopped to start with. Also, these forward and backward pins will be the actual forward and backward pins from your motor driver. In the setup function, I first start the serial, and then I set up the pin modes. So all of these, including the LED for the Bluetooth status, the left and right speed pins, and the directional pins, all of them will be set to output. Here, I'll wait for Bluetooth Low Energy to begin, and if it doesn't begin, then I will print to the serial that it failed. I will also then start to blink the built-in LED to show that there's a problem. With this line of code, I set the local name, so the name that will show up in the chooser menu from the website. this will advertise the service, which would be the car service. And here I'm actually adding the characteristics. So for the left speed and the right speed. Finally, I add the service, Bluetooth car service, and I set event handlers. So when Bluetooth's connected, the BLE peripheral connect handler will be triggered, and for when it's disconnected, this one will be triggered. Also, when characteristic left and characteristic right are written to, their respective functions will be called. Then I set the default values to 100, which means stop. And finally, I call ble.advertise. So this will actually start it to show up in the website. I'll go over this function later, but moving on to the loop, the loop just calls ble.pull, which actually updates and checks for any new information. Now these two functions, they just are called whenever a device is connected or disconnected, and it is so that whenever a device is connected, the built-in LED is on to show that the connection is active. Then this function, this is actually to see when the left motor speed is updated. And all this does is gets the motor speed and then has this check. So when you have a really small PWM value, the motor actually doesn't spin and instead you can hear a small whine. So instead I made sure that within this grace period, so a grace period of 20, if it is above that, right, then you want to go forward. And so I set the forward to high and the backward to low. And then I analog right, so this sets the speed value on the speed pin to a linear map of this. So a linear map, basically what that does is if there's a range, so say from 0 and 10, and another range from 0 and 100, and you have the number 9, and you want to map it to that range. Humans can easily just say that instead of 9, it'll be 90. But computers, they need to have a function like this. So this linear map, it just does a bit of math, and that actually figured out what it will be in the new range. So it's basically going from 0 and 100 to 80 and 255. So 255 is the max speed, and 80 is the minimum speed. And this, if it's lower than 91, so if it's like 90 or lower, it means that it has to go backward. So the same thing. The backward pin is high, forward pin is low, and then maps it. If it is between the grace period of 90 and 110, then it just turns all the motors off. And the same thing for the right motor. Okay, and over to the website. So the website's pretty simple. For the HTML, we only have two parts. One is a connective. This is just a connect button and an error text. And this is the actual remote. So it has two ranges. And these will be the sliders. They go from 0 to 200. And in the JavaScript here, we first set the UUIDs. So this is for the BLE service that I wrote in the Arduino code. And these are for the two characteristics. Here, this just sets the ranges, and then this is just what happens when you release it. So when you drag the slider and you let go, it resets to this value. Then actually let's just start down here. So connect to device. This function is called whenever the connect button is clicked. And what this does is first it tries to set the button text to connecting. And then it actually opens the navigator.bluetooth request chooser. So this, you can choose a device. In here, we do have a filter, and that is with a name prefix of ATEC. So in my Arduino code, I actually called it ATEC car. So I could just specify that. But just in case, I have ATEC in case I want to change the nameplate. And here in the optional services, I have to specify the service UUID. So remember, this service actually has the two characteristics for the left and right motor. So here is when the user selects it, then it gets a device, which it returns the connect. That returns a server. And so the server, we can get the primary service. and we have to specify the UUID, so which one. My Arduino car only has one service, so just that one. Then when I get the service, we have to do a promise on all, and that gets both of the characteristics for the left motor and the right motor. This is then set to the motor variable in the global scope, and I'll get back to this, and it shows the remote and hides the connect button. If there is a problem instead, then it sets the button text to connection failed, try again, and it actually shows what the error is. So going to update left, it just starts a big loop. Update left just gets the value of each of the ranges, and if the value has been updated and isn't the same as the previous values, then it runs right value with the motor 0, so this is the left wheel, and the value, right? Then it updates the previous values to know if it changes, and then it calls update right. So just going to right value real quick. Right value is this function. It tries to make a byte array with the value here as a unsigned integer 8 array, and it turns out it gets the buffer, and this is the part where it actually sends the data. So this sends characteristic dot right value with response, array buffer, right? Okay, going back here. So then this just calls update right, and update right does the same thing for the right one. And as soon as that's done, it again updates left and updates right in a loop. If the value hasn't changed, however, it calls update left calls update right, but update right actually just sets a timeout. So this also stops any recursion or it updating the values too fast. But if it is changing, then it should be updating pretty fast. Okay, just a small demo. So here, I can actually just click connect, and this brings up the request chooser. So here I have my car. Now if I click pair, then it connects to it, and it runs all the code behind the scenes. And then as soon as it connects, it brings up the remote. So now you can just drag these, probably with a touchscreen, and as you can see, you can update the values. When you're done with them, you can just let go for them to go back to the start. Thank you for watching. Please like, share, and subscribe for more videos. Bye!